Hey guys, this is 2.1. We're talking about linear equations, formulas, and the basic quadratic equations. Instead of simplifying or factoring, we are going to work on solving for x in this lecture. Okay, so linear equations just means an equation that makes a line when you graph it. Formulas are just ways to solve an equation or something that has an equal sign that you can plug a term into and find an answer. And then quadratic equations would be more like this. So quadratic means you have some variable squared. Good? All right. So we are solving for x. For number one, it just says solve the equation 3x equals negative 15. What should we know about a linear equation or any equation? The difference between an equation and an expression in algebra is that an equation has an equal sign. Okay? That equal sign is like a wall. It's saying that everything on this side of the equal sign is the same as everything that's on this side of the equal sign. That's why when we're solving for x, we're going to be anything we do to one side of the equal sign, we have to do to the other side of the equal sign. It's to maintain the equality of the equation. All right, so 3x minus 15, or sorry, 3x equals negative 15. What we want to do is get all of the variables on one side of the equation, usually on the left side or on the side where the exponent is a positive number, okay? So now all of our x values are on the left and the x value is positive. So that's a good place to have it. Once you've isolated the variable to one side of the equal sign, you then want to get it completely alone. Right now, x is being multiplied by 3, right? So what we want to do to get x alone is do the opposite of what is happening to x. So x is being multiplied by 3. The opposite of multiplying something by 3 is to divide something by 3. So we're going to take that 3x and we're going to divide it by 3. Anything I do to one side of the equal sign, I have to do to the entire other side of the equal sign, okay? 3x divided by 3, you can cancel out those 3's, right? 3 divided by 3 is just 1. We're left with x equals, and then negative 15 divided by 3 is a negative 5. So we say x is equal to negative 5. You can always check your answer when we're doing these kind of equations by saying 3 times whatever you got negative 5. Make sure it's equal to the other side of the equation. 3 times negative 5 is negative 15, so x is equal to negative 5. Good. All right, number 2 says x equals negative 10 plus 10x. All right, like I said, we want to move all of the variable values or all the x values to this side of the equal sign. Okay, to move this across, we're going to do the same thing to both sides. All right, we're adding 10x, but we want to do the opposite of it. So we're going to subtract 10x. Anything I do to this side, I have to do to this side. Good. And you can either write it as x minus 10x equals negative 10 plus 10x minus 10x, and then see that 10x minus 10x is 0, right? And we're left with negative 10. And here we have two like terms. So 1x minus 10x is a negative 9x. Or you can just say 1 minus 10x equals 9x. 10x minus 10x is 0, and just bring that straight down, and that minus that straight to that. So you can write it all out horizontally, or you can just do the math vertically, whatever is easiest for you. Okay, now we have all of our x's on the left side and all of our constants on the right side. The non-x's are on the right side for solving for x, right? Right now, x is being multiplied by negative 9, so we want to do the opposite. Multiply by negative 9, we're going to divide by negative 9. Anything I do to the left side, I have to do to the right side. So we're going to say positive x, because that was a negative divided by a negative, equals negative divided by negative is a positive. So we're just going to say it's 10 ninths. Or if that's does it tell us what to leave it? It's not a great decimal, so I would just leave it as a fraction. So x equals 10 ninths. Here, x is -5. Here, x is 10 ninths. Number 3, it says x minus 12 is equal to 3x minus 20. I'm going to move all of my x's to either the left or the right. If you want them to be positive numbers, you can move them to the right, but traditionally we move them to the left. It doesn't matter, okay? And then you're going to collect all of the constants on the other side. So since I see a positive 3x and a negative 20 here, yeah, if I prefer to work with positive numbers, I'm going to move this x over here. All right? This x needs to move over here. When we moved this 10x over here, what did we do? We did the opposite of what was happening. It was a positive 10x, so we subtracted 10x. Here it's a positive x, so we're going to subtract x from this side, and we're going to subtract x from this side. What we get is this cancels, so we're left with -12 on this side, equals 3x minus 1x is 2x minus 20, right? We still need to get x alone. So this is 20 is being subtracted from it. I'm going to add 20 to get rid of that. Anything I do to the right side, I have to do to the left side. And what I get is -12 plus 20 is a positive 8 equals, that 2x just comes down, and those cancel. So 8 equals 2x. X is being multiplied by 2. What's the opposite of multiplying by 2? We're going to divide by 2. Anything I do to the right side, I have to do to the left side. 8 divided by 2 is 4 equals x. Okay? I'll do it the other way too. X minus 12 equals 3x minus 20, just to show you that it doesn't matter which direction you move all of the x's to. So I want to move all of the x's to the left this time. Here we moved them to the right. Now I'm going to move them to the left. That's a positive 3x, so I'm going to do the opposite. I'm going to subtract 3x. Anything I do to the left, I have to do to the right. So that becomes x minus 3x is a -2x. -3 plus 1 is -2. That 12 stays the same. Those cancel, and I've got a -20 over here, okay? Next, I want to get that -12 over here. It's being subtracted, so I'm going to add the 12. Add the 12. I put it right below the term it is the same as, so that I can just combine them, right? So that's still -2x on this side. This cancels, equals -20 plus 12 is a -8. X is being multiplied by -2, so I'm going to divide it by -2. The negative divided by the negative cancels, and I just get x equals -8 divided by -2 is a positive 4. So you get the same answer whichever direction you move it. It is up to you. Good? So for number 3, x equals 4. 4 minus 12 is the same as 3 times 4 minus 20. Number 4 is -2x plus 81 equals 7x plus 27, right? If I like my x's positive, I'm going to move that -2x. So I'll add 2x to that side. I have to add 2x to the other side. That cancels. 7 and 2 is 9x. So I have 81 equals 9x plus 27. I'm going to subtract that 27 from both sides. 81 minus 27 is 54. So it's a positive 54 equals 9x. X is being multiplied by 9, so we're just going to divide by 9. Anything I do to that side, I do to the other side. 54 divided by 9, we know is 6. Good, so x equals 6. Those cancel to get x on that side. 54 divided by 9 is 6. Number 5, you want to be careful with the parentheses, okay? 9x minus 4x minus 1 is 2. The first thing you want to do is distribute that minus sign. So 9x stays the same. Now that becomes a negative 4x. And then a negative times a negative 1 is a positive 1, right? Minus a negative 1 becomes a plus 1 equals 2. So we've distributed that minus sign. We can get rid of the parentheses. And we can combine like terms. So the 9x minus 4x, you can just combine them because those are like terms. 9 minus 4 is just 5x plus 1 equals 2. I'm going to move that 1 over. So it's being added. I'm going to subtract it. 5x equals 2 minus 1 is 1. Divide both sides by 5. X is 1/5 for number 5. Good? Okay. Now you're going to see if you look at the answer key, you're going to see it look like this. It doesn't say x equals -5. It just says it opens the bracket, it puts -5 in the bracket, and then it closes the bracket. That just means all possible answers to this linear equation is the term -5. All right, so it's just a different way to write it. Number 6 is 6 times the quantity x plus 7 equals 6x plus 42. The first thing you want to do, so we're just going to go in order of operations. The first thing you want to do is distribute that 6 to the terms inside the parentheses. 6 times x is 6x. 6 times 7 is 42. 6x plus 42 equals 6x plus 42. I'm going to move all of the variables to the left. So the 6x is positive. I'm going to say minus 6x minus 6x. Those cancel, and I get 42 equals, those cancel, and I get 42. 42 equals 42. I don't have any variables left, and that is true. Even if you were to say, okay, now I'm going to move all of the constants over to the right, so I'll subtract 42. If I subtract 42 from this side and I subtract 42 from this side, that becomes 0 equals 0. You still have a true statement. All right, this is true. 42 equals 42 is true. 0 equals 0 is true. 6x plus 42 equals 6x plus 42 is true, no matter what x I put in it. So for number 6, we say all real numbers. 6 is all real numbers. Whatever x I put in there, that equation will always be true because this side is the exact same as that side. You could put in -100, you could put in 0, you could put in 2, it will always be true. Okay? Number 7 is -7x plus 7 plus 5x equals -2x plus 12. Let's try that one, see how it goes. -7x plus 7 plus 5x. Sorry, you can't see that. Equals -2x plus 12. I'm going to start by combining like terms. So -7x plus 5x plus 7 equals -2x plus 12. -7 and 5x become -2x plus 7 equals -2x plus 12. So notice here, for number 6, all real numbers, we had 6x plus 42 equals 6x plus 42. It's the same on both sides. You can stop right there and say all real numbers. That will always be true. That side is exactly equal to this side. For number 7, we have negative 2x plus 7 equals negative 2x plus 12. Not exactly the same, okay? We can keep going. Here, I want to move all the x's to the left, so I'll add 2x because it's being subtracted. Anything I do to the right, I have to do to the left. So that cancels, and we get 7 equals negative 2x plus 2x cancel. 7 equals 12. That is not true. That will never be true. Negative 2x plus 7 will never equal negative 2x plus 12, no matter what x you put in there. Even if you said 0, 0 times negative 2 is 0. 0 plus 7 is 7. 0 plus 12 is 12. 7 is not equal to 12, okay? So this we say no solution. So sometimes your x will disappear, okay? If your x disappears and it's not true, no solution. If your x disappears and it is true, all real numbers. Okay? Number 8 is 6x minus 4 plus 7 times x plus 1 equals negative 5x minus 7. I'm going to distribute that 7. 6x minus 4 plus 7 times x is 7x. 7 times 1 is 7. Negative 5x minus 7. Now I'll combine like terms. 6x plus 7x minus 4 plus 7 equals negative 5x minus 7. 6 and 7 is 13x. Negative 4 and 7 is 3 equals negative 5x minus 7. Now we're just going to move the x over here. It's a negative 5x, so I'm going to add 5x. 13 plus 5 becomes 18x. Over here it cancels, so 18x plus 3 equals negative 7. Now I'm going to move that 3 so that the 18x is alone. Subtract 3, subtract 3. Bring down that 18x. 18x equals negative 7 minus 3. 7, 8, 9, 10 is negative 10, right? One more step. X is being multiplied by 18, so I want to divide it by 18. Anything I do to this side, I also do to this side, so we'll divide both sides by 18. 18 divided by 18 just gives me x. Negative 10 divided by 18. Negative 10 divided by 18 as a simplified fraction is negative 5/9. Why is that? Because, right, if we take, I'll rewrite it, negative 10 divided by 18 equals, and I'll just factor it, negative 10 would be negative 1 times 5 times 2. 18 would be, let's see, 9 times 2, or even 3 times 3 times 2. And what I see, and what I see is I can cancel out those 2's, and I'm left with negative 1 times 5 divided by 3 times 3, which is negative 5 divided by 9. So that's the most simplified you can get that fraction. And that is what they will want it in, is simplified form. Good. Negative 5/9 is our answer. All right, number 9. Number 9 is 6 divided by 2x minus 3 equals 4 divided by 2x plus 5. When you have a fraction, remember what we do with fractions? We multiply everything in the equation by the least common denominator of both the fractions. There isn't really a least common denominator of both of these. Each of these is a binomial, and they are not the same binomial, right? So we're just going to do it one at a time. Okay, I want to get rid of the 2x minus 3 in the denominator. If you want to get rid of a denominator, what you want to do is multiply the whole equation by that denominator. All right, so I'm going to take 2x minus 3, and I'm going to multiply it by 6 divided by 2x minus 3. Good. Equals anything I do to this side, I have to do to this side. So there's that 4, 2x plus 5. I multiplied this by this, so I have to do it to the other side of the equal sign, 2x minus 3. It's not the same as the 2x plus 5. I just have to do it, okay? I'm going to rewrite it as 6 times 2x minus 3 all over 2x minus 3 is equal to 4 times 2x minus 3 divided by 2x plus 5. All right, what I see before I continue, what I see is that I can cancel that 2x minus 3. It is common to both the top and the bottom of the fraction, so I can factor it out, and that's why we did it, right? We multiplied it by that so we could cancel it. We multiplied that side by it so that it would remain true. Anything I do to this side, I have to do to that side. So that now becomes 6 equals 4 times 2x minus 3 divided by 2x plus 5. We're going to do it again. We got rid of the 2x minus 3 by multiplying both sides by 2x minus 3. So now we're going to get rid of the 2x plus 5 by multiplying both sides by the 2x plus 5. Good? Okay. So we will rewrite it as 6 times 2x plus 5 is equal to 4 times 2x minus 3 times 2x plus 5 divided by 2x plus 5. What do I see now? I see that I can cancel that and that, right? And what I have left is 6 times 2x plus 5 is equal to 4 times 2x minus 3. So we started with a scary looking fraction. We multiplied it by both the denominators, first by the 2x minus 3, and then by the 2x plus 5, to get 6 times 2x plus 5 equals 4 times 2x minus 3. It's still a lot, but we got rid of the fractions, okay? Now I'm going to distribute that 6. 6 times 2x becomes 12x. 6 times a 5 is 30. That 4, I'm going to distribute. 4 times 2x is 8x. And then 4 times a negative 3 is minus 12. Now we just have two variables and two constants. We're just going to move them around. There's a 12x and an 8x. I'm going to subtract 8x to get all of the x's on the same side. 12x minus 8x is 4x. Here it's canceled. Plus 30 equals negative 12. Good? Subtract 30. Subtract 30 to get that 4x alone. So now over here we just have 4x. And here we have negative 12 minus 30. They're two negatives, so they're just going to get bigger. So that's negative 42. X is being divided by 4. Or sorry, It is not. It is being multiplied by 4, so we want to divide it by 4. Divide it by 4. That cancels to x, and negative 42 divided by 4 is a negative 21 firsts. Halves. Halves, I apologize. Negative 21 halves in its simplest form. Good. So that is the answer to number 9. X equals negative 21 over 2. You can use Desmos to simplify it, or you can just think 42. I can divide 42 by 2, and I can divide 4 by 2, so I'll factor out a 2. Good? Okay, this number 10 just explains what we did in number 9. If your equation is a proportion, one fraction equals one fraction, use the cross product before solving. For fraction equations with more than one term per side, you can first clear the denominator by multiplying every term by the least common denominator. So we're just going to do number 11 the same way we did number 9, cross multiplying. So it's negative 7/8 x equals negative 2/9. Good? All right, we have the denominators of 8 and 9, right? I'm just going to start with 8. There's nothing common to both 8 and 9, so I'm just going to take everything, multiply it by 8. If I did it to this side, I have to do it to this side. And remember, when you're multiplying, that means it ends up on top. So we have negative 7 times 8 divided by 8x equals negative 2 times 8 divided by 9. Good? All right, what can cancel? This 8 and this 8 can cancel, leaving us with a negative 7x. Nothing really cancels over here. You can multiply it out if you want, but I don't think we need to. So that becomes negative 7x is equal to negative, well, yeah, let's do it, 16 ninths, because 2 times 8 is 16. Good. Here we got rid of the 8 by multiplying by 8. We're going to get rid of the 9 in the denominator by multiplying by 9. Multiply this by 9 to get rid of the denominator. Multiply this by 9 just to make it fair. So now that's negative 7 times 9x equals negative 16 times 9 ninths. Those cancel. 7, negative 7 times 9 is negative 63. So we have negative 63x is equal to negative 16. Good. All right. I'm going to take 16 and divide it. Well, I'm just going to say x is being multiplied by negative 63. So what do we need to do? We need to divide it by negative 63. Anything I do to this side, I also need to do to this side. That cancels, and I just get x is equal to negative 16 divided by negative 63. How can I simplify this? Well, that's an even number, that's an odd number. I can't imagine them having any common factors, but it is a negative on the top and a negative on the bottom. That means you're taking a negative and dividing it by a negative. That cancels and it becomes a positive, right? Because any negative divided by a negative, the answer is going to be positive. Negative 16 divided by negative 63 as a fraction is just going to be a positive 16 over 63. So the answer to number 9 is x is equal to 16 over 63. Good. Okay. For number 12, we have 3/5 plus x divided by 4 equals 20. All right, so clear the denominator by multiplying every term by a least common denominator. Can you get all of those denominators the same? Right? So you can just go through and say, I'm going to multiply this by 5, multiply this by 5, multiply this by 5, and then I'm going to multiply this by 4, and this by 4, and this by 4. Or I can make it a common denominator. right? Can I make all of those equal to something over 20? 3 divided by 5 plus x divided by 4 equals 17 divided by 20. I want them all to be over 20 instead of over 5 and 4 and 20. Yeah? So what you can do is you can say 5 times 4 is equal to 20. If I multiply the bottom of my fraction and the top of my fraction by 4, I will get it out of 20. Yeah? 4, you can multiply it by 5 to get 20. So now I have 4 times 3 over 4 times 5 is 20 plus 5 times x over 4 times 5 is 20 equals 17 over 20. And then you can simplify that further by saying 4 times 3 is 12. 12 20ths plus 5x divided by 20 equals 17 divided by 20. Good. Now you have the same denominator, okay? Once you have the same denominator, you're going to do the same thing we were doing before, which was just, let me rewrite it. 12 divided by 20 plus 5x divided by 20 equals 17 divided by 20. So we're starting with this, right? I want to get rid of that 20, so I'm going to multiply this by 20. I'm going to multiply this by 20. And I'm going to multiply this by 20. Good. So now I have 12 times 20 over 20 plus 5x times 20 over 20 equals 17 times 20 over 20. And I can cancel each of these. Good. So now that is 12 plus 5x equals 17. I'm just going to solve it like there are no fractions because I got rid of the fractions. I'll subtract 12, and what I get is 5x is equal to 5 divided by 5, and x is 1. Good? Okay. Number 13, we have negative 5 over x plus 8 over x equals 17. What is my denominator? It's an x. So I'm going to take each of those, multiply it by x. Take that one, multiply it by x, and I even have to take 7 and multiply it by x. Okay? So now that's x times negative 5 over x plus x times 8 over x equals 7 times x. Rewrite it as negative 5x over x plus 8x over x equals 7x. Now I'm going to cancel those x's. And what I get is negative 5 plus 8 equals 7x. Combine those like terms. Negative 5 and 8 just becomes 3 equals 7x. X is being multiplied by 7, so I'm going to divide it by 7. And my answer is x equals 3/7 for number 13. Good. All right, for number 14, again, when you have fractions, you just want to look for what is the denominator. Whatever that denominator is, you want to multiply every term by it. So here we have an x, a 4, and an x. That means I want to multiply everything by 4x. So this was 5 minus x divided by x plus 3 divided by 4 equals 7 divided by x. I see that I need to multiply everything by x and 4, so I'm just going to say times 4x times 4x times 4x, because those are the denominators that I want to get rid of. I want to get rid of a 4 here, and I want to get rid of an x here, and I want to get rid of an x here. So I'm going to put them all together and get 4x so that I can get rid of all of the x's and the 4's. So that becomes 4x times 5 minus x divided by x plus 4x times 3 divided by 4 equals 3 times 4x divided by x. Before you even simplify 3 times 4x or 4x times 3, this is already factored to some degree, right? So it's factored, and if while it's factored you can see that you can cancel out the denominator, do it right then. So that x cancels out that denominator, that 4 cancels out that denominator, and that x cancels out that denominator. What are we left with? We still have 4 times 5 minus x equals 3 times x equals 3 times 4. Good? 4 times 5 minus x is equal to 3 times x is just 3x. Oh, sorry, that should be a plus. Wow. Sorry to confuse you there. Equals 3 times 4 is 12. Good? What I'm going to do now is I'm going to distribute that 4. 4 times 5 becomes 20. 4 times a negative x means a negative 4x plus 3x equals 12. Let's combine the like terms of negative 4x and 3x to get 20 minus x equals 12. Now, I don't love that that's a minus, but I'm still just going to... If you don't like that that's a minus, you can move it over by saying plus x on this side, plus x on this side. Canceling it out over here, so it leaves you with 20 equals 12 plus x. You can do that if you want, just to get rid of that minus, that negative x. Then you still have a 12 with the x, so I'm going to subtract 12, subtract 12. 20 minus 12 is 8 equals x. Okay? You don't have to do that. You can also just say 20 minus x equals 12. I'm going to subtract the 20, subtract the 20, and I'm left with negative x equals negative 8. You're not done yet. You have to divide by a negative 1 to say x is equal to positive 8. So whichever one of those looks easiest to you. So x is 8 for number 14. X equals 8. Good? All right, for 15 and 16 and 17, we're just going to substitute in a number into an equation, okay, or a formula. So this says that P is always equal to 2 times L plus 2 times W. Good? If we know that P is equal to 28, it doesn't tell us what L is, so we'll just say 2L plus 2, but it does tell us what W is. So instead of P equals 2L plus 2W, P equals 28, W equals 9, we have 28 equals 2L plus 2 times 9. You can simplify that to 28 equals 2L plus 18. Now we're just going to solve for L like we've been solving for X. So subtract 18, and we get 10 equal to 2L. L is being multiplied by 2, so we want to divide it by 2. That cancels, and we get L equals 10 divided by 2, or 5. Good? So you're just substituting in the value they gave you. A is equal to 1/2 of the quantity B plus B times H. Substitute in 58.5 equals 1/2. B is 19. 19 plus that other B is 20. And then don't forget that there's an H times H. So now we have 58.5 is equal to 1/2 times the quantity 19 minus 20 times H. You can simplify that. 58.5 is equal to 1/2 of 39 times H. Good. 58.5 is equal to, what's 1/2 of 39? 19.5. We're not done yet. We still need to solve for H. H is being multiplied by 19.5, so we'll divide it by 19.5. 58.5 divided by 19.5 is 3. So H equals 3 for number 16. Good. 17, V equals 1/3 BH when V is 48. And H is 8. So that becomes 48 equals 1/3 B times 8. What we're going to want to do is multiply the 1/3 times the 8. So it's just 8/3. 48 equals 8/3 B. Okay, now what should we do? Well, if you look at this, 8/3 times B means B is being multiplied by 8 and divided by 3. That means we can take B and we can multiply it by 3 to get rid of that denominator. Anything I do to that side, I should do to this side. So 48 times 3 is 144 equals, that cancels that, 8B. Now B is still being multiplied by 8, so we're going to divide it by 8. 144 divided by 8 is 18. All right, for number 18, we're going to solve the formula for the indicated variable. So we're not going to get a number. We're just going to change this equation around so that T is alone. Right now we have PV equals N times R times T. We want T alone. Okay, so imagine that these are numbers and that T is the variable or the X that we want alone. Just like, well, back at the beginning when we said 3x equals -15, we wanted X alone, right? So we divided by 3. Same thing, we just don't use numbers. We want T alone. Right now, T is being multiplied by R and being multiplied by N. You can do them one at a time if you would like. So, N, T is being multiplied by R. That means we want to divide it by R. Anything I do to this side, I have to do to this side. So now we have PV divided by R is equal to N times T. T is still being multiplied by N. We're going to divide it by N. Here, to divide, you just add it to the bottom of the fraction. So that becomes T equals PV divided by Rn. And it does not matter the order. You could say PV divided by Rn, or you could say PV divided by NR. If we want to solve F equals 9/5 C plus 32 for C, what we're going to do is we're going to work backwards. So we have F equals 9 divided by 5 times C plus 32, the first thing we want to do is subtract 32 because we want C alone. Anything I do to that side of the equal sign, I have to do to the other. All right, these are not like terms. So I'm just going to say F minus 32 equals 9/5 C. Good? Now C is being multiplied by 9 but divided by 5. The opposite of being divided by 5 is to multiply by 5. Get rid of that 5. Anything I do to that side, I have to do to this side. So now we have we have 5 times F minus 32 is equal to 5 times 9 over 5 times C, right? Okay. Why did we do that? We did that so we could cancel the 5, and we get 5 times F minus 32 is equal to 9C. So the C was being multiplied by 9 and divided by 5. We got rid of the 5 to just get 9C over here. Got rid of the 5. The 5 is still over here. Now, it's being multiplied by 9. What do we want to do? We want to divide by 9. Good. So our final answer is 5 times F minus 32 divided by 9 is equal to C. You can also write this as 5 divided by 9 times F minus 32. Good. A equals P times the quantity 1 plus RT. Solve it for R. All right, inside the parentheses, R is being multiplied by T, and then they're going to add 1 to it, and then it's all going to be multiplied by P. So the first thing I'm going to do is I'm going to divide by P. I'm going to get AP. A divided by P is equal to 1 plus RT. Right, now now R is being multiplied by T and 1 is being added to it. We're going to subtract 1 from both sides. So now we have A divided by P minus 1 equals RT. Good. Now we are going to divide everything by T because R is being multiplied by T. So we had A divided by P minus 1 equals R times T. We're going to take that T and put it in the denominator of each fraction. There is no denominator of this fraction, but we're going to turn it into a fraction, put it in the denominator, equals R. So the final answer is A divided by PT minus 1 divided by T equals R. Okay, number 21, they're asking us to solve for Y. We have negative 2x plus 11y equals 22. We're solving for y, not for x, okay? So we want to get the y alone. So we're going to add 2x, add 2x. 11y equals 2x plus 22. Divided by 11, we get y alone. And we get y equals 2x minus 22 over 11.